Hello, CS111 students. This is the problem set video for problem set 6, task 1, predictive text. And it's in the web page at the usual place. I'm just going to walk through it. The background on this task is that we're giving you a chance to look at the algorithm behind what your phone does when you use the phone keyboard to predict the next word. One of the features of modern phone keyboards is that you can type keys, but also just for convenience, there's usually like 1 or 3 different suggestions at the top of the keyboard of what the keyboard thinks the next word might be, and you can just tap one of those to quickly use it. And so the question is, how does the computer know? Right? Sometimes it suggests silly things, sometimes its suggestions are actually really good, and you can just click a bunch of those to type out what you were trying to say anyway, or something close to it. And so we're not going to get into all of the wrinkles of that algorithm, but we will build something that is an approximation of what your phone might use. And the fundamental principle of the algorithm is that it looks at the words that you've typed before. So whenever you're typing anything on your phone, it remembers the words that you type and the sequence of words that occurred. And it sort of distills that memory into a format that it can use to say, well, if you just typed this word, then I think this is the word you're going to type next. So what we're going to do to make things simple is to assume that we have a list of words. That's a list of strings, and each string is a word that the person has typed before. And we're going to try to use this list of strings to make predictions about what they might type in the future, given what they are typing when the prediction is made. So what we're going to do is take a list of words. The example here is she said that she was tired, 6 words. And we're going to build a dictionary out of them. Surprise, surprise, this week's problem set is about dictionaries. So we're going to build a dictionary where the keys of the dictionary are the words that were typed. And the values of the dictionaries are lists of words that were observed to follow the word that was typed. So in she said that she was tired, the word she appears. It appears twice. She said, she was. So we have she as a key in our dictionary, and the value for that key is the list containing the 2 words said and was. So in other words, every time we see a word, we look at the word after it and add that word after it to the possibilities for that word in our dictionary. So the rest of the dictionary that we would build from she said that she was tired, the word said appears once, followed by that. So said is a key, and the value for that key is just a list containing only one word, that. That appears once, followed by she. So that is a key in the dictionary, and the value for that key is a list containing she. Was is a key in our dictionary, with a value just a list containing a single thing, tired. And then tired is not a key in our dictionary because we've seen them type the word tired, but they never typed anything after that. That was the last word we observed. And so tired does not appear in the dictionary, although it does appear as part of the value for the word was. Okay, so this dictionary is representing these chains of possibility of after this word, this is a word that you might type because at some point in the past you typed that word. To make predictions, what we're going to do is we're going to start with a starter word. Let's say it's the word she. And we're going to look in our dictionary to say what words could follow that word. And we're going to pick one of them. And once we've picked one of them, that will be our new next word. And we'll look in our dictionary for words that will follow that word. And we'll repeat this process however many times we're asked to predict. So with this dictionary, if we start with the word she, one of the possibilities is said, the other possibility is was. We pick one of those. Let's say we pick was. Then we look up was in our dictionary. The result would be tired. That's the only word we've observed to follow the word was. So she was tired. And then at that point, we are out of words to predict because tired is not a key in our dictionary. It's a word we've seen before, but not a word we've seen before followed by another word. So in that case, when we see a word that we haven't seen before, what we're going to do is just randomly pick one of the keys of our dictionary. So she said that was, those are the keys of our dictionary. We're just going to randomly pick one of those keys as the next word. So if we do this process, we could get sentences like the following. She said that she was tired. That's our original sentence. We could get that back out of the predictions, right? We pick she, we pick said next, we pick that because we have to. After that comes she, that's specified by the dictionary. After she, we can pick said or was. Maybe the second time we pick was, then tired is going to follow that. Another example. She said that, she said that, she said that, she was tired. So the way these predictions are set up from this single sentence, it can go in a loop where it keeps picking she said, she said, she said, when it has that option between she said and she was. And that loop can repeat as many times or as few times as it might. Another short example, she was tired, right? We could go immediately to was after she. And a final example here is she said that she was tired, that she said that she was tired. Again, not all of these results are going to be perfectly grammatical. In this case, the word that in this sentence, the second copy, so she said that she was tired, that. That word wasn't picked because we observed it following the word tired. That word was picked because we didn't observe anything following tired, so we had to pick something at random, and that's one of the words that we could have picked at random. So, that's the idea here. We're going to take a list of words, build a dictionary of predictions, then take that dictionary of predictions and predict a bunch of words to make up some text. Two parts to this is building the predictions and predicting the text. So part A, build predictions. It's this function that takes a list of words and returns a prediction dictionary, as we just went through. For each word except the last one, we should have a key in the dictionary, and every word that we observe after one copy of that keyword should be in a list following that word. If there are duplicates, those duplicates should be included in our dictionary. So if we see the same pair of words twice, the first word in that pair as a key will have two copies of the second word in that pair inside of its value. Your function should be fruitful. It'll return the dictionary it builds. And you must use lowercase version of all words for both keys and values in the dictionary. So your input, the list of words, might contain some uppercase letters or entire words. We want to lowercase all those things as we're building our dictionary because we don't really care about case. There's some examples here of what those dictionaries might look like. And you can read them for yourself by going to the problem set page. I'm not going to read through them because they're a little bit complicated. But that's build predictions. And as you may be realizing, this problem set is a little bit more do-it-yourself than some of the previous ones have been, right? We're getting towards the end of the course. We're going to ask you to be a little bit more independent and solve a little bit more complicated problems on your own. So we don't have detailed instructions for exactly how to do build predictions. There might be some hints in the rubric that you could check out as far as what is specifically required. But it's up to you to figure out, okay, given this list of words, how do I build this kind of dictionary? Part B is predict text. So assuming we already have one of these dictionaries, maybe we called our build predictions function, how can we use that to predict some text? And so the parameters of this function are 4. There's start word, which is the first word which we're going to use to base our predictions off of. The next parameter is how many, which is how many words to add. The third parameter is predictions, which is that predictions dictionary that we already have, the one that we created using build predictions. And then finally, there's a policy parameter, which is going to be a string, and it's going to be one of the strings first, last, or random. If the policy string is first, then when we're building predictions and we're looking in our dictionary and we have multiple options, we're always going to pick the first option. Similarly, if the policy is last, we're always going to pick the last option. And finally, if the policy is random, we're going to pick a random option. Now, we don't want you to just roll your own randomness or use the random library. You may already know how to do that from previous problem sets. We want you to specifically use the choose randomly function that we have provided for you. So you can take a look at the starter code, see how that function works. You must use that, and the reason you must use that is so that when we grade your code, we're actually going to mess with that function a little bit so that we can make sure that the results are predictable and we can grade whether we correctly used choose randomly. A corollary to that is that not only must you use the choose randomly function, you must use it exactly once, no more than once, for each prediction that you make. And you also have to make the predictions in order, although that's required for other reasons anyway. So, what does this predict text function return if those are the parameters? It returns a list of strings. The first element in that list is always going to be the start word that it was given. And then in addition to that start word, there will be how many extra words, right? That's our second parameter. So if how many is 3, then there will be 4 words in the list that it returns because there will be the start word plus 3 more words. And each of those how many extra words are predicted based on the previous word in the list. Now, there are 2 types of predictions, as I've already hinted at. The first type of prediction is if we see a word, either the start word or the previous word that we're building upon, which is already in our predictions dictionary, we use the predictions dictionary to tell us what are the possible next words, and we'll pick one of those according to our policy. On the other hand, if that previous word does not appear as a key of our predictions dictionary, maybe we gave you a start word that isn't one of the words in the dictionary, or maybe you got to a word in the dictionary where it was the last word of the input, so we have some word that comes before it, but we have no predictions for what might come afterwards. Either way, if that previous word is not a key in our predictions dictionary, then we'll use the specified policy, but we'll feed it the keys of the dictionary as the things that we're choosing from, rather than some kind of value from the dictionary to choose from. And you must specifically use the expression list parentheses predictions.keys, close empty parentheses. You can see it in the problem set. And it's also in the rubric. You must specifically use that expression to convert the keys into a list so that you can pass it to choose randomly or index it depending on the policy. Okay, the entire process is just keep making predictions until you have enough words in your list according to that how many parameter. And we'll always provide the start word in lowercase, so you don't need to worry about that. We know that the predictions dictionary has words that are all in lowercase. The start word is also going to be provided in lowercase, and so your results is also going to be all in lowercase. As I already explained, in random mode, you must call choose randomly once per word predicted. It bears repeating. That's because of the way that we're going to test your code. If you call choose randomly twice and throw away the first result and just use the second, that might work, but the way that we test your code, it won't be the same choices as the solution code makes. Okay, we've provided a function called buildString that will take your list of words from predict text and just build a string so it's a little bit easier to read. You can use that for testing. And so we have some examples in the problem set. Again, I'm not going to go into them. But they involve calling build predictions and then calling predict text. There's also some examples in the starter code for testing that are already set up for you. So, in addition to the testing code in the starter file that just runs some of these very simple tests with short list of words, the fun part about this task is to use it with a large body of text. And then look at the kinds of results that you get and the weird quirks that are in them, because those quirks of the patterns of words and the results from a large body of predictive text will tell you something about the word patterns in that text. So we've gone to Project Gutenberg, which is a place that hosts free ebooks of public domain works, many novels from before copyright was started, for example. And we've downloaded a couple books. You could also download your favorite Project Gutenberg book if you have one in there that you are a fan of. And we've provided a ebook.py file that will allow you to take those ebook.txt files and use them as Python variables. And that stuff's all set up for you in the file already. There's just some tests that you can comment that test it with certain ebooks. And it'll take your predict text function and predict 150 words based on the words that are in the ebook. So you can see what that looks like. Now that's totally optional. You don't have to do it. You could just rely on the simpler tests that are also in there. But it can be a fun thing to do. And if you want, again, you can test it with your own favorite ebook from Project Gutenberg. It's not set up to read just any TXT file, but if you have a different TXT file you'd like to test it with, let me know and maybe I can figure something out. There's also a challenge. This is not an extra goal. This is not graded at all. And I know many of you will probably just not do it because you don't have the time, right? There's a lot of other demands of your time in this class and in your other classes. But if you're interested, the predictions that we're building based on a single word don't do a really great job of predicting what might come next. And we can get better quality predictions if instead of looking at one word, we look at 2 words at a time. So, as a challenge, completely ungraded, not even an extra goal, if you want, you can write a build double predictions function and a predict text advanced function. Build double predictions takes a list of words and should return a double predictions dictionary. A double predictions dictionary, instead of having words as the keys, has pairs of words, a tuple of 2 strings, as its keys. And the format is similar, it still has a list of individual words that might come after that pair as the value. And then the predict text advanced function would take a start word, a how many variable, a single predictions and a double predictions as 2 separate dictionaries, and then a policy, same kind of string as predict text does, first, last, or random. And it should make predictions using those double predictions when it can. So if the previous 2 words are a key in that double predictions dictionary, then use one of the words from the associated value. Or when it can't, because the previous 2 words as a pair have not been seen before, then it'll fall back to the one-word predictions, or if those can't be used, it'll fall all the way back to a random key from the one-word predictions. So, if you do define these functions, our ebook tests will give you 2 paragraphs each instead of just 1 paragraph. The first paragraph with single word predictions, the second with double word predictions. And you can see some of the differences in the ways that the double word predictions are a little bit more accurate than the single word predictions, although they both make a lot of interesting grammatical mistakes. Okay, that is it for task 1 of problem set 6, and there will be other videos for the other tasks.